So if that was easy, how about we do one that's pretty similar to this? Alright, oh shoot. I don't know if you can read it. Okay, so at 69 degrees Celsius, the vapor pressure of pure water is 295 torr, while the vapor pressure of pure ethanol, 46 grams per mole, is about 499 torr. If this is the percentage by mass of ethanol in water is made, assuming Raoult's law is obeyed, what is the mole fraction of ethanol in the vapor phase? Okay, so we know the vapor pressure of pure water and the vapor pressure of ethanol. Okay? Now, there is something you need to know. It's wanting to know the mole fraction of ethanol in the vapor phase. But with Raoult's law, let me write it out here, equals, with this, the mole fraction we find here is actually for vapor, not vapor phase, for aqueous phase, or for liquid phase. It's not for vapor phase. No, the mole fraction for that deals with pressures. The mole fraction in the vapor phase of solute equals the pressure, or the partial pressure, of the solute over the total pressure. That's what the mole fraction is. Reason being is that, you know, pressure is dependent on the number of moles at constant temperature and volume, you know. I could explain why, but it will be outside the purpose of this video. Okay, so we know the pressure of pure water, so standard P for water is equal to 295. We know that from the last problem we did. Okay. Well, the pressure of pure ethanol is equal to about 499 torr. Alright? Okay, so we have those two out of the way. So we also have another mass. So, what do we do? First, let's set up an equation. Okay? So, I'm assuming what is the mole fraction of ethanol in the vapor phase? So, we know what this is. Okay, sorry about that. So, yeah, we have to do this equation for both of these, right? And then, because we need to figure out what the partial pressure is for both of these. And then we can figure out what the mole fraction of ethanol is using this equation, okay? So that's what I see from looking at this equation. We know how to do this part from the last problem, but I'll just go over it again. So we assume 100 grams with this percentage. Since this is 22.9% by mass of ethanol, we can assume out of a 100 gram sample that ethanol is 22.9 grams in that sample. So, ethanol is equal to, no, not equal to, 22.9 grams. Well, water, which I'll just do as H2O, is 100 minus that. So 100 minus 22.9, so 77.11 grams. Okay? So we have the mass. Now we can calculate the number of moles of both. The molecular mass of water is 18, which is pretty darn close to the exact value if I would do say so myself. So 4.28 moles. Alright. We have the molecular mass of ethanol, which is 46. So 22.9 divided by 46. 0.498. So 0.498 mole. Alright? Now we just basically plug it into this equation. Let's do for water first. Okay? So P of water P of water is equal to the mole fraction. Well, what is the mole fraction? Well, water is 4.28 moles. But what is the total? Well, let's just add 4.28 to that. So we have 4.78. 4.78. Okay, now what is the standard pressure of pure water? Well, it's 295. So we multiply that answer by 295. Okay? And that will give us our answer. Well, what does that give us? Okay. So 4.28 divided by 4.7778, which is about 0.896. Oh wait. Times 295. So 264. Okay then, so 264 torr. Alright, so we got that. So now we do the same thing, except for ethanol. Set it up exactly the same. We have 0.498 over 4.78. Remember, the answer is still 3 sig figs in this one. Standard pressure is 499. Remember, these are partial pressures up there. Okay? God, believe that looks like a G. Anyway, divided by 4.78 times 499. Well, that equals 52.0. So 52.0 torr. Now we have to use this equation. Well, what we're looking for is the partial pressure of ethanol in the vapor phase. So we do this divided by this. So 52 divided by, what's the sum of this? 264 plus 52. 52 divided by 316 equals 0.164. Yeah, 0.164 torr. And that's it.